What I have here is an intake manifold from a, I think it's an 86 to 90 Jeep Wrangler. You can see it's the 4-cylinder. And what we want to do is we want to adapt a carburetor to mount where the old fuel injection stuff used to go. The carburetor we want to use is a Weber DG type. This is a DFAV, which is same thing as a DGAV or a DG series. It's got the smaller, or the two different size barrels here, 32, 36, and it's a progressive type carb, so they both don't open at the same time. The little one opens first, and then the second one when you really get into it. First thing to note off the bat is carburetor doesn't fit either way with the EGR valve still attached. So that's going to be the first thing that has to go. I've already got it loosened here. So we'll have to make a block off plate for that too. The way the holes are situated, the mounting holes, we can't mount the carburetor this way because the heads for the bolts that will hold the adapter plate down will intersect with the mounting hole heads. They're just too close. And we want to do this in one piece, not a like a two-piece sandwich adapter. So we're going to mount the carb this way. And that won't affect it negatively in any way. This is just the way it has to be mounted. That center hole is a circle, so no matter which way we mount it, we have to taper the bore to go down from the oval shape down to that circle. So the other thing we have to do also to prep the manifold is to get the studs out, and I already got one of them out, and it looks like they were put in with Loctite. So I'll get the other 4 out, and then we'll start on the adapter. So now with the studs out, we can see just about how the carburetor is going to sit. One problem, just spin it around to make it easier to see. One problem I can see is this carburetor does have some pieces that drop down below the lowest plane, which is this stop right here, which is a throttle stop, so you can only go so far. And the other thing is the accelerator pump. Now, this carburetor needs rebuilt, so it won't open all the way. But even with that, you can see, not opened all the way, the accelerator pump still drops below this lower plane. The reason that's important is normally I like to use half-inch plate for these adapters just to keep the height as low as possible. The 5/16 socket head screws we're going to use to mount this have a head height of 0.32, I believe, and I like to recess those about 2 thousandths, so 0.34 total depth for the recess. If you use half-inch material, that gives you 0.16 below it, which is okay. It's plenty for holding this on. There's not a whole lot of force on it. Anything less than that might start getting into trouble. The problem is these components here drop down about 1/8 of an inch, which means the plane where these mounting bolts are would have to be 1/8 of an inch lower than they normally are with a half-inch plate. All that to say, half-inch isn't thick enough. We're going to have to go to 3/4. That'll give us plenty of room for the drop-down components, the mounting hardware, everything, but it also helps us make a transfer from this spread here to this small round opening. Instead of having something sharp, half-inch thick, and you're going to a sharp taper, 3/4 inch thick, 50% thicker, you've got less of a taper. You still have a taper, but it's not quite as dramatic. So it should help with flow. So for the extra 1/4 inch that we're going to raise the carb up because of the thicker spacer, will eliminate the problems underneath and give ourselves a better flow. So that's what we're going to use, is 3/4 inch. So here's the layout. This is in Kanban. I like Kanban. It's about as basic a CNC program you can use, but it does everything I need to do, so why not? This is the top of the plate. This is everything I've come up with. This has to be done in 2 ops, so this will be the top, and then we'll flip it over and do the bottom. But this will make more sense. We'll walk through it on the machine and see it one step at a time. But this is what I've come up with. So let's head over to the machine and get started. So here we got a piece of 3/4 inch aluminum bar stock, ready to get started. First thing we gotta do is put some, we gotta drill some holes, so we're gonna pre-drill them first. So these 4 will be our mounting holes to go to the manifold, and then these 4 here will hold the carb. So these 4 have to be tapped for studs, and these will just be through holes, countersunk. And I'm going to hit that with a small mill, but if I'm going to do a tool change to drill and tap these ones, I'm going to go ahead and drill them all, get as much material out of the way as possible, try to reduce the chances of me breaking a 1/4 inch end mill. But anyway, we're going to drill all these right now for the drill size for the studs. Not sure if I pushed start on the record button, but anyway, we've got all the holes are drilled, and I just paused the machine because I didn't know if we were rolling or not. These 4 have been drilled so that they can be tapped, but these 4 have been drilled just so they can get the material out of the way, so that I don't reduce the chance of me breaking that 1/4 inch end mill. And then we're going to countersink these 4 holes here for the head of our fastener, but it also has to be opened up just a little bit because the drill wasn't big enough to open it up for the threaded end. So anyway, let's go ahead and do that. So here we got the plate countersunk and bored out for the fastener to fit through. So countersink is good. If I drop that in there, I might not get it out. There you go. That seems to be good too. As long as I have these holes placed right, it should work out just fine. So now we're gonna hog out some material from the bore before we do the taper. Again, just to get it out of the way, give the chips and the coolant somewhere to flow to as we're cutting the taper. But we also have to cut a lower plane on each end for those pieces on the carb that drop down, someplace for a relief for those. So we'll do both of those with the same tool. Now the bore is roughed out, and we have recesses on either side for those components to drop below the lower plane of the carb. And the head, I have to get that burr off of there. So the head should sit just below the surface. Oh, that's good. You can just barely catch it on the edge there. That's great. That's what we want. Okay. Now we're going to use the drag engraver to mark what this actually is, just make it easier to find when I'm looking for it later. Alright, that looks pretty good. Knock that down with the DA once we get it off of here. It just barely raises up an edge. Now we've got a ball end mill here. We're going to put the taper in the bore, and we're going to just scallop these edges on both sides here just to make it look good. Alright, that looks pretty good. Cool. So next we're going to chamfer these holes, and we're also going to chamfer the perimeter, even though I probably should have cut a relief to get some of this material out of here. But even though I didn't, we'll do the chamfer, because once we flip it we won't be able to. We'll just see how it turns out. If it causes a problem, we'll change it for future ones. But anyway, we're just going to run with it for now. That turned out okay. It's a little deeper than I like to go with that chamfer mill, so I may look into changing that process a little, but it worked out okay. Last thing to do from this side is to run the tap through. Alright, that looks pretty good. Get it out of here because we gotta flip it over anyway. Now I got it bolted to a fixture plate. First thing we're going to do is get rid of the bulk of the material around the perimeter. We got our roughing passes done, so we're going to make a finish pass and clean that up. That's a much better finish. The last operation here is going to be to take our ball mill and open this up to the right diameter so we just get a little better flow. There it is. She's all finished. Let's get it off of there and mount it. See how it looks. So here it is. I just dusted it off with the DA. Normally I would tumble it, but for the sake of expediency, and I put some studs in it so we could mount it. One thing with the DGV, since it does have the smaller bore on one side, you want to make sure you mount it whichever way you want the throttle to pull. So ours, if we want the throttle to pull this way, we want to have the small bore on this side. So that way, yeah. So that way we're pulling the throttle that way. So let's get that mounted down. So there it is, the adapter mounted, and the carb slides down right on top. So we still have to make the block off plate for the EGR, but that's relatively simple. With the plate at 3/4 inch and the carb itself, I measured to the bottom of the air filter because the thickness of the air filter can be added to this, and it also includes this area above here. So from the bottom of the carb to the top, or to the bottom of where the air filter mounts, is 3 3/8. So add 3/4 to that, and we're about 4 1/8. So whatever thickness you can get a air filter assembly for, and I've seen them pretty thin, 1.5 inches, 1 3/4, something like that. But you add that to the total, to the 4 1/8, and that gives you a total height to see if it'll fit underneath the hood. So anyway, that's it. Not a difficult project. Turned out pretty nice. Got a nice smooth bore down into the stock intake one. Should have some good flow. Alright, that's it. Thanks for watching.